Okay, I'm going to try to walk you through a problem or two here with the transition metals and bonding. Again, it's following the same steps I've talked about, but we just need to make sure we're looking at the right thing. So in question 1, we're trying to come up with the subscript. So this is our formula. These would be the subscript. So it would be just like writing the formula, Fe subscript, C subscript, right? So we're making the formula for these two elements, iron and carbon. Now, iron is a transition metal, and so you don't know its charge unless it's stated. That's why I state it here. Iron plus 3 is what you're going to be using in this. So the first thing I'm going to do is on a sheet of paper, I'm going to write out that I have iron plus 3. And then I'm also going to have carbon, and I need to know what carbon's charge is. So if I look here on the periodic table, you can see where carbon is on the periodic table. And remember, that's how we figured this out, is this is going to have positive 1, positive 2, positive 3. Carbon, a lot of times, will be a negative in this case. And so negative 4, negative 3, negative 2, negative 1. And so carbon is going to be a negative 4 in this case. So if I come up here, I can now write negative 4 for carbon. And now I'm going to use that where the cross oxidation method. So I'm going to rewrite my elements in the same order. Notice that I have the cation first, that is the positively charged one, and the negative one second. Now with that, I'm then going to take the charge for carbon, and I'm going to move it down here, but it's no longer going to have a charge with it. So it's just a number. So this is now Fe4, it's the subscript. That means I have 4 iron. Same thing with this for iron. I'm going to move it down and cross over to the other element, and it's going to be right here for carbon, okay? Notice that neither of them have a positive or a negative anymore because they're not charges. They now represent how many of this element I need. So I need 4 iron and 3 carbon. Why do I need that? Because I'm trying to get a balance of these charges. And if you do 4 times 3, that's going to give you positive 12. 3 times 4 is going to give you a negative 12. So they would neutralize one another and they would no longer have a charge at all. If I can reduce, I would reduce it this time, but it doesn't seem that I can. And so I can just rewrite this all nice and neat as iron 4, carbon 3. And that's what I would end up putting over here. Let me bring this to the front for a second because apparently it got moved back. All right. So if I come and I try to select here, that was iron 4, carbon 3, okay? Now that I have that one, I can do this next one, and I'm gonna do the same thing. As I do this next one, you see you have Cu, and it has to be +1, it's the transition element, and P. You can look on the periodic table and find out this is copper and phosphorus. Well, move that aside, but let's go ahead and write what we have. Cu +1, P we don't know yet. We have to look on the periodic table. Periodic table, see right here. We have P, that's phosphorus. Notice that it's 1, 2, +3, -4, -3. So phosphorus is a -3. Put that away. And -3. Now I can copy them down. Cation always has to come first. Bring that down here, that down here, and I'm going to get 3 and 1. And this is one of the reducing rules where I said, okay, 3, it doesn't reduce anymore, but I wouldn't have the symbol P if I didn't have at least 1. So a 1 there is redundant. And so that's why I'm going to rewrite it as Cu3P. And that's the answer I need. Now, when I'm answering that on this, what I need to make sure that I do is Cu is going to be 3. So I pick 3. But for P, notice you actually have the statement blank. And that's what you want to pick. You want to pick blank. You don't want to just not select something, but you need to pick blank. Okay? Now let's go down real quick to a naming of one so that you know how to do that as well. So this is the scientific name of FESE. Okay? So in this can be a little bit difficult because you're going to have to figure out what that charge of iron originally was. And to do that, you're going to need to know what both of these elements are. Okay? So let's write down what we have. FESE. Let's move that to the side. FESE. It seems to be a 1-to-1 ratio. Undo that. Move this. All right. So with our periodic table, we can see that Fe is iron. So we're going to write that name, iron. So let's go ahead and do that real quick. Linking these together, that's fun. All right. So, messed up. We don't capitalize it. So it's iron. And then we need to know it's going to have some sort of charge in the middle. And so we're going to write that in Roman numerals. And then to figure out that charge, we're going to have to figure out what this Se is. And if you look, Se is right over here. It's selenium. Now, selenium, a non-metal, we have to make it fit selenide is what we're going to do. And so it's going to be SELENIDE to change it up. Also notice that it is a -2. If it's -2 and that F of E was 1-to-1, then that means that our iron had to be a +2, which means I now know that I do the Roman numeral of 2 right there. And I then can write selenide. It won't show me typing it in on the actual quiz, but trust me, that is indeed the right answer. Iron 2 selenide. Okay, I hope that helps.